Good afternoon, everyone. My name is Nandhakumar from Oath.
My name is LungChih. I'm from Oath. My name is LungChih. I'm from Oath.
Yeah. Welcome to yet another Prometheus talk. We have seen a lot of talks around Prometheus. It's pretty exciting to see the community going on Prometheus. So before I go on, so we are from Oath. How many of you know what is Oath? Wow. Yeah, I'll catch up with you later. I'll get you a swag. Yeah. As he said, Oath is a company created by Verizon when it acquired Yahoo, and it also merged with the AOL and Tumblr, TechCrunch, and all other products. So we are from Oath. Specifically, we work on a core platform which provides the Kubernetes setup for all our media products, which supports Yahoo Finance, Yahoo Fantasy, and front page news, and all these applications run on our Kubernetes cluster. I would like to take you to a journey of how we achieved a good visibility on our monitoring system, very specifically around the Kubernetes clusters. So before I go there, I want to just show you how we started with the Kubernetes itself, right? So we started with a single cluster in a single data center. And the next question comes always, hey, how is your monitoring looking? Yes? We started with the Kubernetes dashboard. It gives you a nice feeling about the CPU usage, the deployment usage, the memory percentage, and also the node pressure details, like how many pods can be allocated and all these details. Is this sufficient for us? Probably not. So we wanted to address this problem in a better way. So we looked at a couple of options we have. So traditionally we monitor. Yahoo has been in the business for 20 years, right? So we have been monitoring all our components using our own agents. So we have OpenTSDB, a pretty solid database out there for monitoring. So we have an agent running. It runs the CPU, collects the memory network details, and all these details are sent to the central monitoring system. So we did the same for our Kubernetes clusters too. We were happy because we were able to get good health about the external system metrics. But we keep getting questions, right? Are we monitoring really the Kubernetes ecosystem rightly? Probably not yet. So then we looked at the search, hey, what's the best way to monitor Kubernetes systems? Back in 2016 I'm talking about. So the first result you get in the Google is Heapster, right? So we looked at, hey, yes, the Kubernetes dashboard is powered by Heapster. We looked at the option to persist that data, because Kubernetes dashboard is real-time. There's no long-term storage, right? We tried with InfluxDB. We had definitely good success with that. I'm not going into much details about it. At the same time, Prometheus 1.x was there. We used Prometheus operator to get started immediately. And just sorry to say that Prometheus 1.x did have some performance issue, could not meet our scale. So we were seeing memories are falling down, and the disk space gets filled up very quickly. So we were trying alternate approach that Prometheus also supports the remote write plugin. So we take that plugin and try to send the data to our in-house system. We were doing a lot of experiment with that. But definitely we were missing some insight into our Kubernetes cluster, which I'm going to talk about it. So on the other hand, so the business is growing, right? We were successful with the Kubernetes setup on one data center. So now we wanted to proceed on multiple data center. So as the cluster grows, here is our footprint look like. So we have 12 independent clusters, 2K workers nodes, and 12K pods and 50K containers across all the stacks, right? So we keep getting questions. Hey, how is your cluster visibility looks like? How much CPU allocations is still available? Do you have a capacity to take more applications on board? So who is the biggest consumer? Like we have a namespace-based isolation. So who is the biggest consumer in our cluster? To answer this question, we sat back and we came up with a bunch of requirements within ourselves. In order to be successful monitoring a Kubernetes infrastructure we need to have an answer to all these questions. So we need to have we need to be monitoring our control plane components, etcd, API server, and any add-ons, you name it. Like we wanted to grab all the dashboards, metrics, and get a visualization out of it. At the same time, so the applications, we are getting more applications. We wanted to make sure we have a good control over our users, like how is the deployment doing, how is the pod doing, even the namespace level utilization. I just want to call out, I don't want to repeat some of the presentation from keynote. Fabian mentioned about the Prometheus 2.x. It's pretty great. So I'm just put those numbers here. It's only Prometheus. We read about the blogs. Prometheus 2.x was pretty great, and 80x improvement in the storage and some compute improvement as well. So we wanted to take a good step on it, and we really spent a good amount of time understanding how Prometheus works and how we can really go further and achieve our goal of monitoring our Kubernetes ecosystem. So next to focus is, of course, I think there was a talk from Bob Cotton yesterday about all the monitoring all the Prometheus metrics available on the Kubernetes ecosystem. So pretty much I listed the same. So we have an etcd, CAdvisor, Kubelet, API server, kubestate metrics from. So these are the pretty important metrics. So we sat and focused on grabbing all of them. Not to mention the Prometheus has a very great service discovery built in. So we use that to scrape any services. You have any services, if you want to scrape all the endpoints, you just need to set one annotation. So we use that to scrape all the Kubernetes metrics into the Prometheus. Not to mention about the file-based discovery, which I'm going to show you right now. So now we listed so many components there, right? So we started with each and every component. One by one, we grab all the metrics. We started with the API server. So we used to hear the file-based discovery, which is not bad. So we have multiple environments. It's a bare metal server, so we have a luxury to hardcode the server name. So we put them in the server list here. We use the service account token credentials. So Prometheus, let's scrape it. So the one another thing is you can see here. So this is how we add the data center label, right? It's pretty cool. So we have multiple data center. If you want to label as well as part of the scraping itself, this is one way of doing it. So this is going to be useful when we see in the federation world. So after we collected the metrics of the API server, then we moved on to other control plane components like etcd and kube scheduler and the control manager. We had some challenge there. So etcd is a huge restriction we have, that the ports are only accessible from master, as you can see in the diagram. So we wrote a simple proxy. So it's a forward reverse proxy. It listens on 5443 tree, and any call comes to that proxy. It only receives /metrics, and it forwards to the local port. So in this case, if etcd is running on 2379, it's going to forward. I'm going to show it right here. Yeah. So as you can see here, it's a parameter 2379 to the metrics API. So the metrics proxy will just intercept the call and forward it to the local host 2379 /metrics endpoint. That's how we collect etcd metrics. Very similarly, we collect the controller, scheduler. So this way, what we have done is we collected all these metrics into the Prometheus. So I'm going to hand it over to LungChih. He's going to talk about what we have achieved with this metrics. So how we came up with the federation.
Thanks, Nanda. So as we mentioned earlier, we have 12 clusters. We have production environment, canary environment. Each of them has 6 clusters. Total, we have more than 2,000 nodes. So these are big clusters. Even Prometheus is very performant. One single Prometheus server will not be able to handle all the data in these clusters. So how do we solve this problem? I think the answer is simple. We need to use federation, right? So Prometheus offers this nice feature called federation. The concept of federation is simple. It's just a hierarchical structure where in each cluster you can set up one Prometheus server, and that Prometheus server will be responsible for scraping data in that cluster. And in addition to that, you can pick one cluster and set up your federated Prometheus server. And your federated Prometheus server will be responsible for scraping data from all other individual Prometheus server. So this is how we make it scale. But in order to do that, there's still a couple of things that need to be done. So the first thing we do is that we aggregate our data. We aggregate our time series. So why do we need to aggregate it? Because by aggregation, we can reduce the amount of storage of our data. And in the federated Prometheus server, we only scrape those aggregated data. So, and of course, another benefit is that if you aggregate your data wherever you need it, you just need to call your aggregation metric, and then your data will be showing up. It's super fast. So, okay, the next thing is, since we reduce the amount of the storage space of our data, and then in the federated Prometheus server, we can have longer retention period. I think for us in our federated Prometheus server, we set the retention period to be 1 year. So, if you want to debug for something or just for visualization purpose, you can just pull data up to 1 year. And the next thing is that since we have our federated Prometheus server, so this becomes the most important server we have, right? So therefore, we need to secure our data in the federated Prometheus server. So we add a permanent storage to that. So in case there's anything wrong goes in your federated Prometheus server, the pod crash, you may want to delete the pod, and after you bring back the pod, your data won't be lost. So they will still be there. And of course, with the federated Prometheus server, you have a unified display for all your data. You don't need to go to one Prometheus server to see your data in one particular cluster, and then go to another one to see data in another cluster. So this is another benefit of using federation. So this is our federation configuration. I think actually we in the federated Prometheus server we script two kinds of data. One is the aggregation data that we just mentioned earlier. The other kind of data is the important Kubernetes components, control plane components. So I think in the red box you can see that we script data for like kubedns, kubescheduler, kubeAPI server, etcd, all those important control plane components. So these are so important, so we don't want to lose any data for them. And you can also see that we scrape data with the name starts with either cluster or Colo. Colo means the collocation. It's just refer to our data center. So these are the aggregation rules that we created. So we also script them here. So let's look at some of the aggregation rules we have. So to start with, we take some of the aggregation rules from Prometheus operator. If you are interested, you can just search it, and you can grab a couple of nice rules there. So it's going to be a good starting point. So in addition to that, we also build our own aggregation rule. So mostly they are for CPU and memory, because these are two most important resources we have in our Kubernetes clusters. So this is an example of our aggregation rule. So this is for CPU utilization. Although the rule looks complicated, but let's first focus on the metrics we use. On the top, we use containers, CPU usage, seconds total. This is the CPU usage for a container. And the label replaces just a function to create another label. In this case, we create a label called controller from pod name. Controller is basically the same as deployment. And we sum up all the CPU usage for all containers in one Colo. You can see in the end of the expression on the top, we group them by Colo. So in the bottom, we use metrics called container spec CPU shares. This is a metric that give us the CPU allocated to a container. So similarly, we sum up this for all the containers in one Colo, and then with all these, and we can derive the CPU utilization. This is similar to the previous rule. The difference is just it gives us a different level of the CPU utilization. This is the namespace level. You can see we preserve two labels, Colo and the namespace. This is one more example. This is for controller level. We have three labels here: Colo, namespace, and the controller. This gives us the pod level, and this gives us the container level. So with all these aggregation rules, no matter what level you want to see CPU utilization for deployment, or for a pod, for a container, for a namespace, or for a cluster, you can use these aggregation rules. So now we have all the data in Prometheus servers, right? So what's next? What should we do with all those data? We want to monitor our system, right? So we want to get an alert if there's anything goes wrong in the cluster. We can get a notification, and then we can fix the problem. So to that end, we use Alert Manager. Alert Manager is a separate library. You can deploy it separately. And it offers a nice feature to help you to manage your alerts. For example, you can use it to group your alerts. You can silence your alerts if you need some time to debug, or you can use inhibition. So it has a nice UI, like the picture showing here. So it's pretty straightforward to use. So let's take a look at example of the alert rules that we have. In example, this is for node not ready. So we use the metric called the kube node status condition. This metric tells us which node is going down. We also add some useful labels there. For example, severity, in this case is warning, and the Colo environment. With Colo and the environment, we can tell which alert it is coming from. This is another example of the alert rule we have. In this example, we use the aggregation rule we mentioned earlier. This is for CPU utilization. If the CPU utilization for a namespace goes beyond 75%, then we will get this alert. You can see that the severity is critical in this case. So with the severity, you can deal with alert differently. For example, if it's a warning, you may just receive email notification. If it's a critical alert, you may want to page your on-call and fix the problem immediately. So this is the alert template. Basically, if you use the email notification, it's gonna be the same as you can see in your email. It lists all the labels, and it also has description, summary. You can add some basic debug steps there, and when you receive this notification, pretty much you have everything to deal with this alert. So, of course, we couldn't miss the most important alert, which is to alert on our Prometheus server. Obviously, if Prometheus server goes down, none of this will work. So to do this, we set up an alert in our federated Prometheus server. And if there's if any individual Prometheus server goes down, alert will be triggered in the federated Prometheus server, and we will receive the notification. As for the federated Prometheus server, we can have a simple cron job that runs periodically to check the status of our federated Prometheus server. If there's anything wrong in our federated Prometheus server, you can receive notification for this. So next, I'm going to hand over to Nanda to talk about the dashboards.
Yeah, thanks, LungChih. Before I actually dive onto the dashboards, any guess? So we mentioned that we have 2,000 servers. Any guess how many alerts we may be getting in a week, or in a? He's my manager. He knows everything. Yes. How much? 50. It's pretty close. Not too close. So we get close to 4 alerts a week. We have 2,000 bare metal servers. Like, servers keep going every day. At least 1 or 2 servers keep going down. So some of the concept in the alert manager, LungChih covered that you can. So we set the severity to warning if one node goes down, so we don't get paged for that, of course. So if there's a critical alerts, we get paged. So we come up with complex alerting rules. Say, if there's 1 node goes down, don't alert. If there's a 10 node or 10% of the node goes in a cluster goes down, then page me. So all these things possible with alert manager. It's a similar expression you use for dashboarding also. Yeah, thank you. So I really want, so now we have, as he mentioned, the one application of using the data is for alerting. The other application is, yes, we wanted to use these data for dashboarding. That was our initial goal. So not to bore, it's going to be exciting. I'm hoping that we really got a good product out of it. So the first dashboard, so we came up with the executive stats on our cluster. It shows how many nodes, how many deployments, how many namespaces. So this is all a federated dashboard. You can drop down. In a drop down, you can choose a particular data center. You will be able to get in a single data center stats. The next one is the cluster view. This is pretty cool, right? So within a single place, we're able to achieve what's happening on the entire cluster. So this gives this dashboard helps us with the capacity planning. It basically shows how much headroom we have for supporting new applications, and also what is the current utilization of the cluster. This is pretty cool. I think some of the all these dashboards are derived from the alerting rules, so the aggregation rules we wrote. The next one is a namespace in a multi-tenant environment. So we have close to 80 to 100 namespace, and we wanted to be able to figure out who is our biggest user and how are they performing in terms of usage. Like, are they consuming? Are they being a good citizen, getting a good CPU utilization? So all these things we were able to track it from a single place. So this is pretty cool. So this is one of my favorite dashboard. It's a deployment. So as you can see here, there's a green and yellow. So that shows that the previous release and the current release. So from a single plane, we were able to observe the differences, the memory difference and the CPU utilization difference over the week. Is there any previous releases, current release caused any code issue or anything like that? And an application user is able to enjoy watching the auto scale happening and container restart count. So it's pretty useful for our application team. Not to mention, we have a lot of Kubernetes control plane components here. So the controller, scheduler, we pretty much, watch all these dashboards. Like for a controller, we have a CPU usage. We have each and every controller emits some metrics: horizontal pod autoscaler, deployment controller, daemon set controller. You can pretty much watch how these controllers are performing. Scheduler, right? So we have something similar for API server. So API server is the core here, right? Like you have all the clients talking to API server. You have a daemon sets, or a deployment, or a controller, kubelet, even your custom controllers. They all talk to API server. We had ran into a couple of issues where the API server was throttling from the Go client. So we saw a flat line on this QPS for a particular client, so we were able to catch it pretty nicely from these dashboards. So the kubelet, we have 1,000, 2,000 nodes. So drop down and select a node and observe how is the Docker latency, how is the runtime latency, everything. Thanks to, I think Tom also showed this dashboard. So we just grabbed shamelessly from the CoreOS repo, and we are able to get a good view about the HCD metrics. This is one of the interesting dashboard. So we had a war room for alerting session. So one of the challenges we had was we have so many systems. It's hard to track which machine has which package version. So we came up with a tool. We just wrote a simple script which labels a node with the Docker version or dbus version or RPC bind, some critical daemons. So from a Grafana with a pie chart plugin, we were able to get a good visualization around it. Not to mention, so the scale at which we operate is that we have 25 million time series flowing onto the Prometheus, and we be very careful about this. Is the yellow line is the Prometheus Federation time series. So even though put together we have close to 25 million, excuse me, Federation just have 3 million. So we get what gets into the Prometheus Federation. So that way, as he mentioned, we were able to provide a long retention. Yeah, so that's it from us. I can be reached on Twitter, and the dashboards we have demoed here, it's all available on the my GitHub repo. Yes, Thomas is working on a good approach of how to share the dashboards. So eventually, we will try to use the KSONet, Kubernetes mixin. So right now, these are plain JSONs out there. Feel free to try out. Thank you.
Thank you.
Thank you. I got a question there. Yeah, that's a great question. So we have 2 data centers. So the one we shown in one data center, the diagram was simplified version. So we chose we have 6 data centers totally. We chose 2 data centers for a federation. So. How do you use these dashboards? Do you have them up on screens around some control room, or just getting them up to problem? Yeah, we were just discussing this morning. I should have got some picture of what our TVs. So we have a 15-member team, and we have a couple of TVs. So these dashboards just revolves there. And of course, we have alerting too. We have a Slack integration, so we get alerts. But when we come to an office, we get a good view of our cluster status. Hi.
Do you have a single Grafana dashboard like for everything, or you can just have a global overview and you can just drill down to other Grafana instances?
Right, everything is independent Grafana dashboards right now, but you can just drop down and get to a different dashboard. I believe Grafana has a drill down version of getting into a dashboard. I think we should be working on that. Hi. Sorry, can you repeat? Yeah, so the question, do we have any redundancy on the federated? We have 2 data centers scraping the federated metrics. So if one goes down, we have another one. Yeah, Prometheus is a single server one. So for federated, we just have 2 servers running in 2 data centers. So.
Why don't you use the remote rate endpoint to integrate? You mentioned you use OpenTSDB, so why do you use that instead of just push it off to your central metric system?
Right. The question is, why don't we use that? Yeah, so we did try with Prometheus 1.x. So that time, we were not able to, Prometheus 1.x was not able to scale our need. We were filling out disk. So we went on another route of trying with remote write. Now with the 2.x, we don't see any issue, like 80x improvement in the performance. So right now, the storage is able to handle 1 year worth of retention. I was just talking to Gautam in the afternoon. We would probably try Thanos or a couple of Cortex, right? So the couple of plugins they're working on. So we would be trying with that for a long-term storage. Yes, sir.
How do you actually secure this federation link? So you are sending the data through the public internet?
Right.
Wired?
Yeah. The question is, how do we secure? So we have multiple data centers. How do we secure the federated Prometheus scraping? It's a big organization. Some of these problems are solved for us. So we have an ingress controller sitting in front of every Kubernetes cluster. So we were able to jump onto that securely. So in Yahoo, we have internal ports. It's not publicly open. When it traverses through a Colo to Colo, a data center to data center, we have a data center level encryption. So it's taken care of by the infrastructure team. Thank you so much.
Thank you so much.